Hi, welcome to the answers to your first unit test review for physics. So I'm just going to go through these. I'm going to work through all of them. This is going to be pretty long because we're going to work through them. So the first question asks, how many significant figures are in the following? And if you remember, we did the United States and we had Florida, Texas, and we have the decimal here. And we said all and then non-zeros. So we would normally go ahead and say that our precision's all the way to the end, but for the purposes of physics, and since I didn't write the test, what you're going to do here is you're going to assume that the decimal is here, so that would put the decimal here. So when the decimal is here, we just go with the non-zeros. So how many non-zeros do we have? 1, 2, 3, 4. So we go 1, 2, 3, 4. So my answer is 4. Because this decimal is after, the zero is after the decimal, these zeros before the decimal don't count. So again, when you're here, we don't count the ones before, so this is 1. And I hope that makes sense. We can cover that again in class tomorrow. Now here, the decimal's present, so we're on the all side. So this is going to be 1, 2, 3. And then here, no decimal present, so just the non-zeros, so just 1. Here the decimal is present, so it's all, so that's 3. Here the decimal is present, so 1, 2, 3, 4. Here the decimal is not present, so that is not significant, so this answer is in fact 2. And those are the answers to number 1. Let's move on to number 2. Convert the following into scientific notation. So we're going to swoop and loop. We're just going to move the decimal. 1, 2. So this is going to be 1.423 times 10 to the negative 2, because I moved the decimal 2 spots to the, to the negative 2 is wrong. To the 2. There we go, to the 2. Because we just moved the decimal 2 spots to the left. Here, I'm going to go 1, 2, 3, 4. So this is going to be 2.3. 1, 2, 3, 1, 2, 3, 4 times 10 to the negative 4. Here, we're going to go 1, 2, 3, 4, 5, 6, 7. So that's 1.5 times 10 to the 7th. Here, 1, 2, 3, 4. So 5.6 times 10. We went this way, so that is a negative 1, 2, 3, 4. I lost track. Negative 4. So those are the answers to number 2. Moving on to some actual physics. What is the difference between distance and displacement? Distance includes the total meters or yards or miles traveled. Can't put a D there. That's ugly. Traveled. And then displacement is the distance you are from the start in like a straight line. So that's like when we were talking about how far I was standing, how many squares I was standing from the stool in the front of the room. So what's the difference between speed and velocity? So for average speed is going to equal distance divided by time, and you're going to need to know this for the test. And then average velocity equals displacement divided by time. Now, what does that mean? It means this is how fast you're going. and this is your speed and direction, which leads us into part C. So distance has no direction, so we say that that is a scalar. Okay, whereas displacement, V means vector, and that means vectors have a direction. So displacement is how far you are from the start, and that's going to have a direction. So that's a vector. So along those lines, speed is how fast you're going, no direction. So that is a scalar, but velocity is how fast you're going and your direction, so that is a vector. Acceleration is your velocity change over time, so that's going to be a vector. Volume and mass, we haven't talked about it at all, but does volume have a direction? No, so that's a scalar. Does mass have a direction? No, so that's also a scalar. So remember, scalar equals number, vector is number and direction. All right, what is the average velocity of a car that drives from here to Oregon, 1,300 miles away, in 16 hours? So what we need to do is we need to go ahead and we need to identify what we're looking for. And wow, that is not a highlighter. How come that's not a highlighter? 1,300 miles in 16 hours, and I'm looking for the velocity. So let's go ahead, and I've got V equals, I don't know. I do know I have 1,300 miles, which is a distance, and I have 16 hours, which is going to be a time. So I'm going to use this formula to solve for velocity. It's velocity equals displacement, just d over t. So I'm going to go ahead and I'm going to have 1,300 divided by 16, which equals, these are miles over hours, which equals 81.25 miles per hour. Now if you look, I have two significant figures here, two significant figures here, so that's going to be 2 sig figs. It's going to be 81 miles per hour. 81 miles per hour, that's my answer. So how much time would it take to drive a golf cart 2,000 meters at a speed of 8 meters per second? I have no idea what that is, but it needs to go away. What is going on with that line? Let's see if I can get rid of that. Okay, so I've got 8 meters per second, that's my speed. Speed equals 8 meters per second. 2,000 meters is equal to my distance, and I'm solving for time. So how much time would I have? So I'm going to use this formula, speed equals distance divided by time. Remember the triangle, so you look at your formula. I'm going to put your capital T. The D is on top of the line, so my D is on top of the line. The S is on the left, the S is on the left, the T is on the right, the T is on the right. So I'm solving for time, so I'm going to cover up the T, and I've got D divided by S. So that's going to be D divided by S equals T, and that's going to be T equals 2,000 divided by 8, which equals 250 seconds. So that is my answer there, 250 seconds. Number 6, a blue whale swims Don't mock my whale. It's cute. Swims at 10 miles per hour from San Francisco to San Diego, which takes 75 hours, so that's a time. How far apart are the two cities? So how far apart, I'm solving for distance. I don't know. So I'm going to use this formula, S equals D divided by T, and I'm going to plug in 10 equals D divided by T. Again, you could use the triangle here if you wanted to. So if you cover up the T, it's going to be D divided by S. I'm actually going to solve this one algebraically. I'm actually going to multiply both sides here by t, which my t's not there. I want to multiply both sides here by t, so these t's would cancel, and I would have, sorry, back up. I don't know what I'm doing here. I got ahead of myself. 10 equals d over 75. I'm solving for d. Yes, solving for d. Much better. So I'm just going to multiply 75 by both sides. That makes much more sense. So that's 750 miles equals my distance. And that is the distance from San Francisco to San Diego. All right, Marissa travels to the top of a 100-meter high Six Flags tower. She waves to her friends and loses her shoe. So let's draw the tower. Okay. So Marissa's up here. I don't know how she loses her shoe, but her shoe falls off. So let's draw a little shoe with a little shoelace. And the shoe's going to fall, and it's 100 meters. So that's my distance. And I know nothing else except I want to know how long. So I'm trying to solve for t equals. So if I drop my shoe off this tower, what is affecting the shoe? And I know it looks like a present, but it's not. So the only thing affecting the shoe here is gravity. I know gravity. Gravity is the acceleration due to gravity is 9.8 meters per second squared. So I have an acceleration and I have a distance. So I'm going to use this formula. It's going to be d equals 1/2 acceleration times time squared. So I'm going to plug my numbers in. I've got d and I've got a. I'm going to solve for t here. So I have 100 equals 1/2. You're going to put that in parentheses when you do it in the calculator. 9.8 times t squared, and that's going to give you it's going to give you 200. I'm going to multiply both sides here by 2. So let's do that to get rid of the 2. So 2 here, and then I multiply by 2 here, and that's going to give me 200 equals 9.8 t squared. Now you divide both sides by 9.8, and that's going to give you that t squared equals 20.41-ish. And then you take the square root of that, so take the square root of both sides. So type in square root of 20.41 in your calculator, and that's going to give you t equals 4.717 seconds. So in sig figs, that's approximately 5 seconds. Okay, we're going to use this number to go ahead and solve this. So how fast will it be traveling before it hits the ground? So basically I want to know its final velocity at the ground. So here at the top, how fast was the shoe going before she dropped it? The initial velocity would be 0. And I want to know how fast is it going here. So I have the acceleration, I have the time, I have the initial velocity. So A equals V2 minus V1 divided by T. I know that this is 9.8. And it is going to be, it's actually negative 9.8 because, towards the ground. And then it's going to be V2 minus initial velocity. Initial velocity is 0 minus 0 divided by 4.717 is going to give me a final velocity. So basically here this is going to be negative 9.8 equals V2 divided by 4.717. And all I'm going to do is multiply 4.717 times negative 9.8, and I'm going to get V2 equals negative 46.2 meters per second, which just means I'm falling to the ground at a speed of 46.2. It's negative because I'm falling down. And that's that.